Chapter 8 is on finding roots and radicals. So the first question here is, what is the square root of a number? So to find the square root of a number, we're really asking what, when you square it, gives us the number that we're given. So if I want to take the square root of a, the question is more like x squared equals a. What number, when you square it, gives you a? Okay. Alright, so the positive or principal square root is written with this symbol, the square root symbol. If I want to know the negative square root, I'll write the negative in front of the square root. Okay, more definitions here. That square root symbol is also just called a radical sign. Sometimes I want to talk about radicals that aren't square roots, like cube roots or so on. They'll still use this radical sign, but they'll have a different index. So this is our radical sign. It always represents the positive square root. Also, the 0 is not positive, so if you have the square root of 0, it is 0. Okay. And some more words right here. We have the radical sign. The number inside is the radicand, and the whole expression is called a radical. So I'm looking at square root 2. I could call that radical 2 as well. It's radical. The radicand is 2, and the radical symbol is this symbol right here. Okay. Now, when we're talking about square roots, the square roots of 25 are 5 and negative 5. 25 has two square roots. It has the principal or positive square root, and it has a negative square root. Because both 5 squared and negative 5 squared are equal to 25. Okay? So when I was writing those down as square roots, I would write them down as the square root of 25 is 5. And the negative square root of 25 is negative 5. Okay, so the positive or principal square root and the negative square root. Okay, so 25 has two square roots, but there's a difference in whether I write this out in English or whether I write it out in symbols. The symbol only has one answer, right? The square root of 25 with this symbol. The symbol implies the positive square root, and this symbol wants me to get the negative square root. But if I write it out in English, the square roots there are definitely two answers. It's the symbol that defines which answer you want. Okay. Now, a perfect square, is a number whose principal square root is an integer. So, like 25 or 9 or 4, those are perfect squares because their square root is going to come out to be a whole number. Okay, let's list all of the perfect squares from 0 to 225. Okay, 0 is a perfect square because its square root is 0. 1 is a perfect square because its square root is 1. 4 is a perfect square because its square root is 2. 9 is a perfect square because its square root is 3. And the easiest way to actually write these down and remember them is just to go 3, 4, 5, 6, 7, and so on, and square that number to get the perfect squares. So the perfect squares are 0, 1, 4, 9, 16, 25, 36, 49, and so on. If we square 8, 9, 10, 11, 12, 13, 14, and 15, we can get the other perfect squares all the way from 0 to 225. So 49, the next perfect square is 64, the next one is 81, then 100, then 121, then 144, then 169, 196, and 225. Okay, so the only numbers that have integer square roots are these perfect square numbers right here. These are our perfect squares. They're perfect squares because their square roots are whole numbers, and you can see that we haven't missed any whole numbers here. We've gone right from the whole number 0 to 15, so no numbers got skipped. So there are no other numbers all the way up to 225 that have perfect square roots. Okay. Now here we've got a couple numbers off of our list, or this one right here's off of our list. This is 10,000. It is a perfect square root. It is a perfect square root of, hang on, count the zeros, 1, 2, 3, 4 zeros, so that's 100 times 100. Because 100 has 2 zeros, and you do 100 times 100, you'll get 4 zeros. So its square root is 100. Okay, it's easy to do with powers of 10 if they have an even number of zeros. Okay, just have that. Or you can use your calculator. Okay. The negative square root of 49 is negative 7. Okay, think about this as the square root of 49 bit right here as being the 7, and you just keep the negative. Okay, so it's negative 7. And find all, okay, so it's written in English here, find all the square roots of 289. Okay, 289 is off my list right here. I think it's 17, but let's go ahead and check this. Remember when I'm using my, turn it on, when I'm using my calculator has a square root button on it. I hit second and then the square button to get the square root in blue. And I'll do the square root of 289. I think it's 17. Yep. Now, when I use that button on my calculator, I've typed the symbol for the positive or principal square root. There's not a button for the negative square root, but I know that the other one is negative 17. Or if I wanted to, I could type negative, and then the same thing, square root of 289. Okay, but that is to say, when it's written out in English like this, hitting the button once is not enough. Find all the square roots of 289 are 17 and negative 17. It'll always be positive and negative the same thing, because two negatives will square back to positive 289. Okay. Alright, a few more square roots to evaluate. Square root of 36, that's 6, because I know 6 squared is 36. The square root of 1/9. Now for this one, since I know that fractions multiply tops together and bottoms together, I can just take the square root of each piece. The square root of 1 is 1, and the square root of 9 is 3. 1/3 times 1/3 is 1/9. Okay. If I have a subtraction to do on the inside of the square root, we'll follow order of operations and finish that first. So 33 minus 8 is 25, and the square root of 25 is 5. Okay. In part D, these are square roots that we're going to do first. Then we'll do the addition. Addition is always last in order of operations, unless it's on the inside of something. So the square root of 144 is 12, plus the square root of 25 is 5, equals 17. Alright, on to objective 2. So this one says, race cyclists use the formula v equals 4 square root of r to determine the maximum velocity v in miles per hour to turn a corner with radius r in feet without tipping over. What is the maximum velocity the cyclist should travel around a corner with a radius of 9 feet without tipping over? Okay, so that radius is 9 feet. So v equals 4 times the square root of that radius of 9. So v equals 4, that's 4 implied 4 times the square root, so it'll be 4 times 3 equals 12 miles per hour. So 12 miles per hour is the maximum speed that they should go around a quarter of radius 9 feet without tipping over. Oops, I need to go to the next page, just need to scroll down. There we go. Oh no, that was the bottom. Okay, next page. Objective 3. Use a calculator to find the decimal approximation for irrational square roots. Okay, so if we're trying to take the square root of a number that is not a perfect square, like we know that 30 was not on our perfect square list, it's going to be irrational. Okay, so let's look at a couple of these right here. 100 is rational because I know that it does come out to be a whole number. The square root of 100 is 10. Okay. 4981, this is also rational because it comes out to be a fraction of whole numbers. That's the negative square root, so it's going to be negative the square root of 49 is 7 over the square root of 81 is 9. Okay. Now, the square root of 30, as I just mentioned, is going to be irrational. It's irrational because it's not going to be a whole number. I know 5 times 5 is 25, 6 times 6 is 36. This is left in the middle. It's going to be some decimal. So let's try it. The square root of 30 is 5.4772. 5.4772. Let me just check my 2 right there to make sure that was rounded correctly. Yep, 5.4772. And so on. Okay. The next one, the square root of 72, it's also going to be irrational. I don't know the square root of 72. It's not a perfect square. The square roots that are near it are 64 and 81. what's in between them, so don't know. So we'll look at the square root of, oops, I hit the wrong key. Hit second. Square root of 72. 8.4853. So on. It's irrational. Okay. Now, the difference between these two right here, this one was the negative square root. This one is the square root of a negative 16. So this is asking what number, when I multiply it by itself, gives me a negative 16. This is going to be not real. It's not real because if I have a number squared, it's two of the same exact thing. Two negatives are a positive, two positives are a positive. There's no way to get a negative by squaring something, so there's no way to take the square root of a negative number. So if the inside number is negative, then the square root of a is not real. Okay, so the square root can have the negative on the outside, but never on the inside. There's just no answer to that. It's not real. And I can show that in my calculator by if I take the square root of that negative value, it'll say non-real answer in my error right here because it's not real. Okay. Square root of 8.1. Let's give this one a try. It's also going to be irrational. Okay, so that's irrational, and it's 2.8460. 2.8460. So that's irrational. And it looks like the rest of these right here are irrational too. Let's use the calculator to approximate this expression. Okay. So, following order of operations, this division bar right here is going to be a operations divider. So I'm going to complete the entire top and then divide everything by 6. Okay. Now, I want to make sure that my answer is correct to 3 decimal places, which means I need to keep at least 4, minimum of 4, until I get to my final answer. So keep 4 during my work. Okay, so we're going to first of all figure out what the square root of 321 is. So that's 17.9165. 17.9165. So I have negative 5 plus 17.9165 divided by 6. Okay, so then we're going to add the negative 5. So we've got 12.9165 divided by 6 equals, only for the final answer are we going to round to 3 places. So 2.153. Oops. 2.153. Always keep more places than you're going to eventually want during your work. Now we can also have done that in one line, so let's go back and try that again. If I use my parentheses, I can type the negative 5 plus the square root of 321. Hit the over key to get out of your square root, then close your parenthesis, then divide by 6. So let's check that our decimal places match up. They do, because I kept so many places earlier, it matches up exactly right there, so that's good. Okay. Alright, before we can think about higher roots, okay, so we're going to do some higher roots here, cube roots, fourth roots, and fifth roots. We need to talk about the perfect cubes, perfect fourths, and perfect fifths. So we already know some of the perfect square numbers are like 4, 9, 16, and 25, because 2 squared, 3 squared, 4 squared, and 5 squared. Okay, perfect cube numbers are going to be 8, 27, okay, 2 to the third is 8, 3 to the third is 27, 4 to the third is 64, and 5 to the third is 125. Okay, then perfect fourth powers, 2 to the fourth is 16, 3 to the fourth is 81, 4 to the fourth 4 to the 4th